Factoring is sum or difference of cubes. So if I have two things being cubed that are being subtracted, first you take the original a minus b. You have a squared plus ab plus b squared. If I have two things being cubed that are added, I get a plus b, a squared minus ab plus b squared. So notice, the only thing that switches between these two formulas is a couple signs. So the first sign matches the original. The second sign is the opposite of it. So if I have a positive and negative, I have a negative, positive, always positive. So minus is minus plus, always positive. Plus is plus minus, always positive. So if I'm given, for example, 1,000 plus z cubed. Well, 1,000 is the same thing as 10 cubed plus z cubed. So that's the way we could rewrite it. Now I have two things being added that are cubed. So first I take the two and keep them the same, 10 plus z. Then I square my first term, so 10 squared is 100, minus multiplying them together. So 10 times z is 10z, always positive of z squared, the second term being squared. So a difference of cubes would look like this. You could then go about seeing if this factors down further, but a lot of times it won't. So say, for example, I have 81a to the 6th plus 3b cubed. Well, they share a 3 in common. We can actually pull the 3 out front. Then I'm left with 27a to the 6th plus b cubed. I could rewrite this as 3a squared cubed plus b cubed. So now I have two things being added that are cubed. 3 stays out front. I'm going to add them together, so 3a squared plus b. Square the first term, so 3 squared is 9. A squared squared is a to the 4th, because 2 times 2 is 4. Minus timesing them together. So 3a squared times b is just 3a squared b. Squaring the second piece becomes plus b squared. So factoring would look like this. We pulled out a common, and here's our sum of cubes being factored. Say, for example, I have 64x cubed minus y cubed. Well, that's the same thing as 4x cubed minus y cubed. First term cubed minus the second term cubed. Same pattern in that we take the original function without the cubes, square the first term, so 16x squared, opposite sign is a plus, times the two things together, I get 4xy, always positive, squaring the second term, y squared. One last example. If I have x minus 3 cubed plus y cubed, sum of cubes, so x minus 3 plus y, keeping the original, squaring the first term, so x minus 3 squared, timesing them together, x minus 3 times y, always positive, and this should have been a negative. So you got to catch your sign sometimes, because this one stays the same, this one's the opposite sign, always positive, y squared. So I could go about simplifying this piece if I want to FOIL this out, distribute, combine like terms, but I'm going to leave it in this format for a minute so you can see it. But we can go about simplifying just so you have a reference. I'd be perfectly fine if you left it like this, but here's just for to show you the algebra of what would happen. If I have x minus 3, that's the same thing as x minus 3, x minus 3. And if we FOIL, we'll get x squared minus 3x minus 3x plus 9 out of this first term. Distributing through, I have negative y times x, so negative xy. Negative y times negative 3, so positive 3y, plus y squared. I'm just going to rearrange the terms in the front, guys, so the variables are next to each other. But I didn't change anything inside of it. I'm just rearranging. X squares, there's no other x squared, so it's the only one. Negative 3x is negative 6x. Negative xy plus 3y plus y squared plus 9. Just to list the variables first and the number last.